Hello everyone. Thank you very much for joining today's GOWIN webinar introducing GOWIN's family of automotive products. My name is Jack Russell Bruce, GOWIN FAE for the EMEA region, and I will be presenting today's slides. This webinar will include an introduction to GOWIN as an organization, then a segment on what makes GOWIN's automotive products qualified for the automotive market, a brief view of devices included in GOWIN's automotive range, a study into some applications for GOWIN's automotive range of devices, and then a look at GOWIN's full range of devices, including the 55nm b flash-based devices, the 55nm SRAM-based Aurora devices, and the new 22nm SRAM-based Aurora 5 family of devices. We'll finish by taking a look at GOWIN's free-to-license and easy-to-use EDA tools, including their qualifications to automotive standards.
Now for a brief overview of GOWIN Semiconductor. GOWIN was founded in 2014, and its executive headquarters is located in San Jose, California. Our operational headquarters is located in Guangzhou, China. We also have offices worldwide in locations such as Hong Kong, the UK, South Korea, Taiwan, and Japan. With over 250 employees worldwide, we serve the low to mid-range density markets for FPGA needs, from as low as 1,000 LUTs to over 100,000 LUTs. For more information about GOWIN Semiconductor and our latest innovative products, please visit us at gowinsemi.com. At this time, I would like to start our main presentation.
GOWIN has three device families: the 55nm b flash-based devices, the 55nm SRAM-based Aurora devices, and the new 22nm SRAM-based Aurora 5 family of devices. The 55nm b flash-based devices occupy the low-density market, with products ranging from 1K to 9K logic densities. These compare with Lattice's XO, XO2, and XO3 devices, Intel's Max 10 devices, and Xilinx's Spartan 3 and CPLD devices. The 55nm SRAM-based Aurora series occupies the low to mid-density market, with devices ranging from 10K to 55K LUTs. These compare with Lattice's ECP range, Intel's Cyclone 4 and 5 range, and Xilinx's Spartan 6 range. The 22nm SRAM-based Aurora 5 series occupies the mid-density range, with 15K to 138K LUT devices available. This family is competing with Lattice's Crosslink NX and Certus NX families, Intel's Aria 5 and Cyclone 4 and 5 families, as well as Xilinx's Artix 7 family. GOWIN Semiconductor has been manufacturing automotive-grade FPGA since early 2018, providing fully certified AEC-Q100 Level-1 and Level-2 non-volatile flash-based and SRAM FPGA devices that support a wide range of interface standards, including MIPI-DPHY and LVDS. GOWIN are working with leading automotive companies, delivering solutions that have successfully passed rigorous qualification before moving to full production. Some automotive applications for GOWIN FPGA are shown here, with a GOWIN FPGA bridging camera data to an SoC, converting DSI to LVDS with DDR3 memory for SoC to display communication, and as a PCI to CAN bus controller. For some insight into the automotive FPGA business, automotive FPGA has seen rapid growth, with smart electric vehicles being the driving force. China's BYD has overtaken Tesla as the world's largest electric vehicle manufacturer. GOWIN has invested in a new regional sales office to specifically support our rapidly growing Japanese automotive business. GOWIN has VIP customer status with TSMC China. Monthly shipments currently amount to between 1.5 and 2 million devices, with over 90 million total devices shipped to date. Volume lead times are typically targeted at between 10 and 12 weeks. GOWIN's main assembly and test house, Weichang, is located in Xi'an, China, and GOWIN is currently in the process of adding non-China country of origin manufacturing capability to future devices. GOWIN is fully certified by the ISO 9001 quality management system, certified for R&D quality management, supplier quality management, customer quality service, and quality control. The automotive market accounts for around 35% of GOWIN's total China revenue in 2022. GOWIN is the first China-based FPGA company to achieve mass production of automotive-grade chips. GOWIN's customers include most of the major Chinese automotive companies, including BYD, Geely, and Changan. We also have many ecosystem partners, including SoC companies like MTK, Unisoc, Autochips, and Allwinner, as well as AI companies like Horizon Robotics and Black Sesame, and display panel suppliers like BOE, Truly, and CSOT. Besides ecosystem partners, we have also delivered many solutions working together with third-party design companies and Tier 1 suppliers. As of June 2023, more than 3 million automotive-grade FPGAs have been delivered and more than 20 automotive solutions have been released. Striving for continuous improvement, GOWIN is certified by the IATF 16949 quality certification with the aim to prevent product defects and provide reliable devices to every customer. GOWIN is certified by the ISO 9001 standard to improve product performance, meet customer expectation, manage the quality of their products, and demonstrate our commitment to quality. GOWIN also strives for environmental excellence, implementing an environmental management system, or EMS, via the ISO 14001 certification, committing to reducing our environmental footprint to make the FPGA industry as sustainable as possible. GOWIN demonstrates that their testing and calibration laboratories operate competently and generate valid results in line with the ISO/IEC 17025 qualification for reliability and failure analysis to promote confidence in our work from both our partners and customers. GOWIN's partners are along the ride for quality excellence, from manufacture to package and testing. These include TSMC as our wafer partner, Huiqian and JCET for packaging, Lidar and VTest for testing, and Gigaforce, Martech, and China ISTI for reliability and failure analysis. GOWIN is proud to announce it has recently been awarded ISO 26262 certification for its FPGA design environment. The GOWIN EDA FPGA design environment has been certified compliant with the ISO 26262 and IEC 61508 functional safety standards by the TUV testing laboratory. Certification of the FPGA design tool provides strong assurance to automotive OEMs that module designs featuring a GOWIN Aurora 5, Aurora 2, or b FPGA can meet the requirements for system-level functional safety specified in the ISO 26262 and IEC 61508 standards. This is great news for the automotive industry. Along with GOWIN's current qualifications to AEC-Q100 Grade 2 and AEC-Q100 Grade 1, IATF 16949, ISO 9001, ISO 14001, and ISO/IEC 17025, GOWIN FPGA can provide greater solutions to the automotive markets in Europe, North America, and Asia. GOWIN Semiconductor has been manufacturing automotive-grade FPGA certified by an ISO 9001 quality management system since early 2018. providing fully certified AEC-Q100 Level-1 and Level-2 non-volatile, Flash-based and SRAM FPGA devices that support a wide range of interface standards. For the little b range of products, this includes the GW1N LV2 in a QN88 package, the GW1N LV4 in a QN88 package, the GW1N LV9 in both a QN88F and a QN60 package. For the Aurora 2 line of devices, this includes a GW2A LV18 device in both a QN88 and BG256 package. And for the Aurora 5 family of devices, this includes a GW5A LV25 device in a PG256A package, a GW5A LV138 device in a UG324A package, and a GW5AT LV138 device in a UG324A package. All devices listed are qualified to IATF 16949, ISO 9001, ISO 14001, and ISO/IEC 17025. Taking a quick look at the 55nm Flash and SRAM based devices, the little b GW1N Flash-based devices and Aurora 5 GW2A SRAM based devices offer a range of products with logic densities spanning 2K LUTs all the way up to 20K LUTs. Both families offer a range of features, including block SRAM, user flash, PLLs, LVDS, and MIPI-DPHY, and are available in the QN88, QN60, QN88F, and PG256 packages. The Aurora 5 GW5A 22nm SRAM-based automotive FPGAs come in two flavors, a 23,000 LUT device and a 138,000 LUT device. Both offer 27x18 multipliers, PLLs, LVDS, and DDR3, with the 138K device also offering 8GB transceivers as well as up to 8 lanes of PCIe 2.0. Package options for these devices include the PG256 package as well as the UG324 package. GOWIN has supported MIPI-DPHY since our very first FPGA device. Since then, various MIPI-DPHY options have been developed to support our growing FPGA family. For the little b and Aurora, that is the GW1N and GW2A families, soft-core RX and TX are supported up to 1 gigabits per second. The little b GW1N LV2 device will support 4 lanes of hardcore RX MIPI up to 1.2 gigabits per second. The Aurora 5 GW5AT 138K device supports softcore both MIPI-DPHY and CPHY. Softcore MIPI-DPHY up to 1.5 gigabits per second RX and up to 1.6 gigabits per second TX, and softcore MIPI-CPHY up to 1.1 gigabits per second both RX and TX. This device is also capable of hardcore MIPI-DPHY up to 2.5 gigabits per second RX. The rest of the GOWIN GW5AT family, that is the 60K, 25K, and 15K LUT devices, support both MIPI-DPHY and MIPI-CPHY softcore and hardcore. Softcore DPHY up to 2.0 gigabits per second RX and TX, and softcore CPHY up to 1.2 gigabits per second RX and TX. The rest of the range also supports hardcore MIPI-DPHY RX up to 2.5 gigabits per second and hardcore TX up to 3 gigabits per second, as well as hardcore CPHY up to 2.5 gigabits per second RX and 3 gigabits per second TX. For GOWIN Semiconductor, Infotainment applications are the backbone of our automotive business, accounting for around 80% of all our projects. GOWIN FPGA is used for video bridging, splitting, merging, frame rate conversion or FRC, and video scaling. GOWIN FPGAs are regularly used with MTK and Unisoc platforms because of the shortage of display interfaces on these SoC chipsets. It's worth noting that Qualcomm SoC chips generically have sufficient display interfaces and require much less bridging. Let's take a more in-depth look at some automotive applications for GOWIN FPGA. This diagram describes an SoC to display bridge for use in the cabin displays of an electric vehicle. Here, a GOWIN Aurora Series GW2A LV18 FPGA is converting DSI and DPI data to LVDS for displaying data to multiple screens within the cabin of the electric vehicle. Many SoCs used in EV processor applications have limited display support. A GOWIN FPGA can be used to expand the capacity to many more displays. The GOWIN FPGA bridging application is useful for multi-channel expansion, using multiple screens, and image scaling. This slide gives you an idea of a real-world application for GOWIN's automotive FPGA series. Here, a customer has employed two GOWIN automotive FPGAs as part of a multi-screen MTK platform. An MTK SoC transmits DPI data to a GOWIN Aurora Series GW2A 18K device to expand to two rear pillow screens over LVDS. Meanwhile, the SoC also transmits 4 lanes of MIPI data to another Aurora Series GW2A 55K device to display video to 4 screens at the front of the cabin via LVDS. Both GOWIN devices are equipped with DDR3 memory for image buffering as used in this example. Mini LED local dimming is another typical use case. To achieve the best display effect, the background lighting board is divided into hundreds of small blocks. The FPGA is used to receive image data and calculate the background lighting of each small block and drive the LED array. The video output is then sent to the display, and simultaneously the smart lighting information is passed to the LED driver via SPI. This solution is in mass production on the Lijiang L9, with new applications currently in the pipeline. The local dimming solution previously featured has been adopted by Chinese automotive company Lijiang and used in their L9 series of electric vehicles, released in June 2022. Subsequent models from Lijiang, including the L8 and L7 electric vehicles, have all adopted this local dimming solution using GOWIN's automotive FPGAs. The cumulative sales volume of this opportunity is over 300,000 devices to date. A video of the solution in action can be found on GOWIN's YouTube channel titled Local Dimming Solution in Automotive Industry. The Lijiang local dimming solution was specified for a 4.82-inch 800 by 166 RGB LCD display at 50 Hz, and used a GOWIN Aurora Series GW2A LV18K device in a QN88 package. The SoC provided video data via RGB888 and background lighting information via SPI for the FPGA to process. The FPGA encodes the video data and streams over 5 LVDS channels, while calculating the background lighting conditions for the display backlight to be transmitted over SPI once more. In this example application, a GOWIN automotive FPGA is being utilized within a camera monitor system, or CMS. Multiple camera inputs are fed to a SerDes receiver within the FPGA. This can be MIPI, LVDS, etc. The image data is then processed, scaled, rotated, and adjusted to the demands of the solution, before being transmitted via SerDes to multiple displays within the cabin. An FPGA is ideal for a CMS solution because of the shorter delay time in comparison with an SoC. Furthermore, camera monitor systems make great applications to feature GOWIN's new Aurora 5 GW5AT products, which feature hardcore SerDes transceivers. GOWIN's IP applications team is currently at work designing a custom ISP IP for this very application to provide an advanced ISP solution for CMS. Advanced Driver Assistance Systems, or ADAS for short, are perfect applications for GOWIN's automotive FPGAs. Like previous solutions where a GOWIN automotive FPGA bridged video data from an SoC to a display, FPGAs can also bridge video data from input sources back to the SoC. In this application, the FPGA operates like a high bandwidth bridge. Camera sensors transmit multiple lanes of MIPI CSI data to a GOWIN automotive FPGA, which receives this data, applies relevant image processing, and transmits the processed images to an SoC or CPU via PCIe 2. GOWIN is currently hard at work on ADAS application design opportunities. For light detection and ranging, or Lidar applications, FPGA plays a great role. A GOWIN automotive FPGA collects data from Lidar module sensors and processes the image data, which is then forwarded to the SoC. Data processing modules are the most important part of a Lidar application, as the processing algorithms are incredibly complex. The benefit here is the FPGA is offloading this processing from the SoC using complex algorithms to deliver excellent Lidar imaging at minimal cost to the SoC processing bandwidths. In this solution currently provided by GOWIN, an FPGA is employed to cooperate with a microcontroller monitoring the health of an SoC. The FPGA can be overridden by the MCU to display warning icons separately from the SoC. A master controller monitors for abnormalities in the SoC, providing image data of warning icons via SPI for display if something goes wrong. The FPGA will then save the last frame of dashboard image and overlay the related warning icons and drive the panel. At the same time, the MCU will reset the SoC or the whole system if required. Not all applications for GOWIN's automotive FPGAs are limited to cabin display systems. GOWIN automotive FPGAs can also be employed for use in electric vehicle powertrain applications, such as in a PWM controller solution. In this high-end microcontroller IGBT driver, a GOWIN FPGA is controlling the output of 6 lanes of PWM waves, monitoring the output of the Texas Instruments DSP SoC for abnormalities when receiving abnormal currents or voltages. This solution utilizes a GOWIN b 4K GW1N4 device. GOWIN's automotive FPGAs can be used outside the car, in charging systems. This real-world application using a GOWIN automotive FPGA involves a small GOWIN b GW1N 1K device bridging MIPI to LVDS data for an EV charging display. Let's take a deeper look at GOWIN's 3 families of products. Introducing GOWIN's first device family, the GW1N b family. This 55nm Flash-based non-volatile family of FPGAs supports standard interfaces such as JTAG, SPI, and I2C. Logic density ranges from 1K LUTs to 9K LUTs. The base family including a 1.5, 2K, 4K, and 9K LUT devices, with low power 1K and 2K LUT devices available, as well as 2K, 4K, and 9K automotive devices. GOWIN's b series also makes use of System-in-Package or SiP technology, offering FPGAs with on-chip memory and SoC options. Product competitors include Lattice's XO2 series of devices and Intel's Max 2, 5, and 10 line of devices. GOWIN's second device family, the GW2A Aurora family, is a 55nm SRAM-based family of FPGAs aimed at more complex solutions. Logic density ranges from 10K LUTs to 55K LUTs. The base family including 20K and 50K LUT devices, as well as 20K automotive devices. GOWIN's Aurora series makes use of system-in-package or SIP technology as well, offering FPGAs with on-chip flash, RAM, and SoC options, with a 10K LUT device available in the form of the GW2AN9X with on-chip flash. Product competitors for this range include Lattice's XO2, XO3, and ECP series, Intel's Cyclone 4 series, and Xilinx's Spartan 6 series. GOWIN's newest family of devices, the GW5A Aurora 5 family, is an ultra-low power TSMC 22nm SRAM-based family of FPGAs aimed at the mid-density market. Logic density ranges from 15K LUTs all the way to 138K LUTs. The base family including 25K, 45K, 60K, and 138K LUT devices, 25K and 138K LUT automotive devices, and a range of devices with transceivers, the AT range, including 15, 60, 75, and 138K LUT devices. As before, the use of SIP technology continues, offering FPGAs with on-chip RISC-V and ARM Cortex microcontrollers in the AST range of 25K and 138K devices. Product competitors for this range include Lattice's Crosslink NX and ECP5 series, Intel's Cyclone 4 and 5 series, and Xilinx's Spartan 6 and Arctic 7 series. All GOWIN products are available to view on GOWIN's website, www.gowinsemi.com. GOWINSemi.com has dedicated pages for each line of products, for easy maneuverability and access to all the information you might need. GOWIN's website includes a members area. It is free to become a member and allows the user to download the EDA tool, other software, and documentation such as product datasheets and user guides. To become a member, head to register/member login in the top right corner of GOWIN's website, or head to the URL on this slide, www.gowinsemi.com/en/member. All GOWIN products are programmed using the GOWIN EDA tool, which has recently been certified compliant with the ISO 26262 qualification. The tool is free to download and is also freely licensed. To download the tool, head to www.gowinsemi.com/en/support/download_EDA or click the link on this slide. GOWIN EDA supports Windows 7 through 11, as well as XP in 32-bit mode. Linux is also supported for CentOS 6.8, 7.0, and 7.5, as well as Ubuntu 18.04 and 20.04 LTS. GOWIN's extensive IP core library within GOWIN EDA is all available for free and is being continually updated with new IP, the latest additions including SLVS ECRX, 10 gig serial Ethernet, EDP encode and decode, and USB to multi-serial protocol bridge IPs. GOWIN EDA is a fully featured EDA environment and includes a free IP core generator, floor planner, timing constraints editor, schematic viewer, hierarchy viewer, GOWIN's GAO analyzer oscilloscope, project archiving, module encryption, and a standalone programmer. GOWIN is partnered with Metrics for Premier ODM simulation. It is a fully featured, high-performance simulation environment supporting System Verilog, Verilog, and VHDL, as well as UVM and VUnit. Metrics DSIM Cloud utilizes scalable cloud computing resources, offering no limitations on performance, no licensing restrictions, and minimal local hardware requirements.
All right, thank you, Jack, for that presentation. We're moving to the Q&A portion of the webinar. Please send us your questions and we will answer them now. If we end up running out of time, we will answer those questions through email. All right, so let's take a look here. All right, so question number 1. GOWIN has recently added a new GW5AT15 device to the Aurora family. Is that available as an automotive qualified device?
Hello there. Thanks, Andrew. So I'm Danny Fisher. I'm the Senior FAE Manager at GOWIN EMEA. Let me field these questions. Yes, so eventually, multiple package options across our new Aurora 5 family, including the GW5AT15, will be made available as automotive qualified devices. The AEC-Q100 automotive qualification typically takes more than 12 months. It's quite a rigorous qualification process, which means that these new devices are not yet available as fully automotive qualified parts, purely because of the length of time it takes to achieve the qualification. However, these new devices have been developed on the TSMC 22 nanometer low power process mode. And this technology process was specifically pre-qualified with automotive applications in mind, which should make it easier to achieve the full AEC-Q100 qualification. So I think hopefully that answers the question. Not fully qualified yet, but work in progress, and there will be a range of package options available for that device.
Yeah, awesome. All right, Danny. Next one I have here is, why should we use GOWIN FPGAs? Why not use FPGAs from analog devices or companies like Xilinx?
Okay, that's an interesting question. I mean, there's a whole range of reasons why you might want to use GOWIN devices over some of our competitors. I mean, if we look back at the recent chip shortage, which I know had a massive impact across the industry, GOWIN Semiconductor were one of the few FPGA companies, in fact, the only one that I'm aware of, that continue to be able to deliver with reasonable lead times throughout the chip shortage. Our lead times on average were maybe 12 to even 18 months shorter than many of the competitors. That put us in a very, very strong position throughout the chip shortage. We continue to have very low lead times and very good availability of devices. I mean, that's one of the many reasons. GOWIN devices do offer a number of technical or technology advantages over the competition as well. For example, the new GOWIN Aurora 5 product family are the only FPGA family available anywhere to offer MIPI-DPHY as a hardcore RX and TX. GOWIN were also the first FPGA company to offer additional on-chip memory, so using our system in package technology to combine multiple die onto a common substrate. We were the first FPGA company to start offering additional on-chip memory on our devices, since followed by some of the competition. So in many respects, although GOWIN are a relatively newcomer to the global FPGA market, we're really paving the way with some of our innovation and technology. If you want to find out more about our products, please do reach out. We can set up calls separately and run a full introduction to our product range. It's probably not enough time here to do it justice. Thank you very much.
All right, thank you, Danny. Next question I have here is, what's the difference between AEC-Q100 Level-1 and Level-2 devices?
Okay, that's a great question. So an AEC-Q100 qualified device means that the device has passed specific stress tests that guarantee a certain level of quality and reliability. So I guess I should start with saying that all our devices are extensively tested. As is typically the case of any IC, they go through a rigorous set of HTOL testing, but the AEC-Q100 extends that. It adds in additional tests, additional stress tests, And what we're looking to do there is to guarantee the lifetime of the device, or the quality and reliability of that device over a long period of time. And we do that by stressing the device under very rigorous test conditions to really simulate long-term aging in a shorter space of time. And there are actually, to come back to the original question, there are actually 4 AEC-Q100 grades, which correspond to the maximum recommended operating temperature ranges that the devices should adhere to in order to guarantee the operating lifetime of the device. So grade 3 is the lowest grade of device. It's typically -40 to 85 degrees centigrade. Grade 2, -40 to 105 degrees centigrade. So typically many of the GOWIN's devices are grade 2 devices. So that takes us up beyond the usual industrial temperature range, which stops at 100 degrees C. And then we have grade 1, extended range, -40 to 125 degrees C. We have a number of devices undergoing qualification for grade 1 currently. And then we have another extended range for grade 0 devices, which really take us from -40 up to 150 degrees C operating temperature. So those are really the grade levels, so 4 grades of AEC-Q100. And again, if these are available in a range of different package options, so the grade 1 and grade 2s may not be available in the same package options, but we have those details and we can share them with you if you're interested. Okay, thank you.
All right. Thanks for that one, Danny. Next one we have is, if I want to package my own device as an SoC, can I buy known good dies from GOWIN?
I guess the short answer to that is possibly. It really depends on a number of factors. It depends on the particular device, the quantities, also the end application to a certain extent. So we do have the ability to provide bare die. Typically, we do that for projects that require very small devices, perhaps medical, hearing aids, those kind of applications where it makes more sense to bond the die directly to the substrate. We're also seeing increasing demand for bare die for things like AR glasses, where the electronics are embedded into perhaps the frame of the glasses, and therefore it needs to be very compact and very small. So yes, we can support bare die, but we do very much look at it on a case-by-case basis. Again, if you need that capability, if you have a device in mind, please do leave your contact details and we can follow up and have a discussion.
Next up, we have, if I can't get samples from Mouser.com, how do I order samples for development?
Yeah, okay, so we have an established range of distributors, both across Europe and the US, who can help with samples. We typically support a small quantity of samples for prototyping for commercial projects, and we can provide samples via our distributors without any issues at all. So if you're struggling with Mouser, if it's a commercial project, please do reach out and we can help.
Excellent. Okay, next up I have, are all the GOWIN EDA versions functional safety certified?
Okay, so I guess much like the AEC-Q100 silicon test, the EDA certification, which is actually managed or done in conjunction with TUV, takes a considerable amount of time. I mean, typically more than 12 months. So the way that we handle this is very much like the other FPGA vendors, is that we do not functionally safety certify all our EDA tool versions, we take a snapshot and we run through the qualification on that snapshot. The latest tool version for the functional safety is GOWIN v1.9.9. That tool release includes our latest families for Aurora 5, GW5AT138, GW5A138, and GW5A25. It also has the latest IP cores in there for the SerDes, for the PCIe Express as well. So that's the version linked to the current TUV certification. Moving forward, I would imagine that we will recertify our EDA tools perhaps once every 12 months to keep up to date with packages, IP offerings. So GOWIN release a new version of EDA tools roughly once every 3 months. The good news is that the EDA tool is always backwards compatible. So we're very careful to make sure the continuity is kept there. And the reason why we do that is because the tools are completely self-contained. So whenever we add new device options, new package options, new IP cores, we update the EDA tool. So yeah, so the functional certified EDA tool is very much a snapshot based on EDA version 1.9.9. It is available to be downloaded from the GOWIN website. If you go to the EDA download page, the EDA tool version is clearly marked as being TUV certified with that version for ISO 26262 and IEC 61508. Okay, thank you, Andrew.
Of course, Danny. All right, got another one here. You showed an example of GOWIN using GOR IGBT drivers for motor control. My application relates to controlling car headlight LED drivers. Has GOWIN used this before?
Using IGBT for high voltage LED lighting control. It's not an application that I'm personally familiar with, but we do have extensive LED control experience and IGBT as well. So we can share that with our applications team and see if we have any experience or anything to share regarding that application. We can certainly take a look at that.
All right, looks like that is all for questions. Thank you everyone for participating in today's webinar. A recorded video of this presentation will be available by tomorrow, and you'll be sent a link directly to the email that you used to register. This concludes the webinar. Thank you, stay safe, and have a great one.